Welcome back, children. Now, in the previous video, we have been discussing about the differences between aerobic respiration and anaerobic respiration. And in that video, I have clearly explained you about the process, how to prove the process of anaerobic respiration. In that, you came to an understanding that even though some organisms are not supplied with oxygen, even in the absence of oxygen, through a process called fermentation, what will be undergone? Respiration will be undergone. That is anaerobic respiration. Which respiration, ma? Anaerobic respiration. Now let us start with another concept today. Here, a scientist called Lavoisier, and you all know him as, he is the person who coined the name oxygen. So Joseph Priestley is the scientist who proposed that there is existence of oxygen and every organism is existing its life because of the presence of oxygen in the atmosphere. Okay, who discovered oxygen means Joseph Priestley. Who coined the name oxygen means Lavoisier. In the 18th century, he is the person who proposed that respiration is also a process of combustion. What did I say, you ma? Respiration is a process of combustion. It's a slow process. It's a slow process. That means there is equality between respiration and combustion. In a comparison, in 1783, he proposed that respiration is a process of combustion. Respiration is a process of combustion. Okay, so the same thing was proposed even by Robinson. Robinson. And you came to know about this combustion in your chemistry, if I am not wrong. Okay, in your chemistry, in your 10th or 9th maybe, you will be going to this term called combustion. So what is combustion? Burning a substance. Burning a molecule. Burning a substance is nothing but combustion. What is that? Combustion. Okay, so is there any difference between respiration and combustion? Respiration means combination of or combining this glucose molecule with oxygen. What is that, ma? So, when we combine glucose molecule with oxygen molecule, this is called as what? Respiration. But when you come to combustion, what is this? Combustion. So, combustion is nothing but heating. Heating of a substance is combustion and combining oxidation of a substance is respiration. So, almost both the processes are sailing in the same boat. Both work on the same phenomena, but still there are some differences between respiration and combustion. Respiration and combustion. Let us see the differences between respiration and combustion. So you all know that oxidation of food material. So what do you mean by oxidation, ma? What do you mean by oxidation? Addition of an oxygen molecule is called as oxidation. Addition of an oxygen molecule to a substance is called as what? Oxidation. Here what we are doing is oxidation of food material, especially glucose, fatty acids, amino acids. Amino acids are nothing but proteins. Fatty acids are made up of fats. Okay, so that means carbohydrates, fats, proteins. So when they are oxidized means when they are supplied with oxygen. When they are supplied with oxygen, it gives what? Energy. It releases out carbon dioxide and water with 686 kilocalories of energy. You all know this very clearly in your previous classes. So this is what? Respiration. So respiration is nothing but oxidation of food material to derive what? Energy. Oxidation of food material to derive energy is called respiration. What will be released in it? Carbon dioxide and water will be released. But when you take combustion, what will happen in combustion means directly the sugar burns. You will take sugar molecules and you will burn it. First of all, it burns and water and carbon dioxide are produced. What will be produced? Water and carbon dioxide. Here also water and carbon dioxide will be produced. Okay, ma'am? So, sugar burns. Here sugar will be burned by providing external source of energy. Whereas here, addition of an oxygen molecule will happen. Here we will provide some external heat to burn this sugar molecule. Here, no external heat is applied. So, we need not provide any gas or any electric current or anything else to derive energy. The heat present in our body itself is sufficient to combine what? Glucose molecule with oxygen. Glucose molecule with oxygen. Here, no external in respiration. No external heat is applied in respiration. Okay, and now when you take combustion, external heat is applied. All of you know that sugar should be burned with the help of some heat. So sugar burns with the help of heat energy. So external heat is applied in the process of combustion, whereas no external heat is applied in respiration. No external heat is applied in respiration. Now, so as there is no production of heat or there is no external heat is applied, what will not happen? No charring of the. What do you mean by charring? Okay, coming into black color. So that is charring. What is that? Charring. Okay, so as no external heat is applied, we cannot say that the glucose molecule, whatever it is glucose, fatty acids, amino acids, they won't get charred. They won't turn into black color. Okay, so no charring occurs during oxidation of sugar. Whereas here we are heating sugar directly on a burning flame. Okay, so that is why what is there? Sugar first of all melts. Sugar melts first. Okay, so sugar first melts and then it becomes black in color. What is that? It becomes black in color. So that is called as what? Charring. What is that? Becoming black in color is nothing but charring. So that is called char. Okay, so charring and later burns to produce flame. Later burns to produce flame. So first of all, what will happen? When you take sugar and when you heat sugar on a plate or something else, what will happen? First of all, the sugar will melt. Later on, it becomes black in color. Nothing but charring. What is that called? Charring. Afterwards, it produces flame. It produces flame. So when you take respiration, there will be several intermediate products formed. Okay, so several intermediate compounds will be formed in the midst of what? So in the oxidation of glucose, before the energy is derived, there will be in the midst of this reaction, in the midst of this action, so many intermediates will be formed. So many intermediates will be formed. Here, no intermediates are produced. Directly the sugar burns. It will melt, it will char and it will produce flame. No intermediate compounds will be formed. Whereas when you take respiration, in the oxidation of glucose, that means C6H12O6, when it combines with 6 molecules of oxygen, so for it to produce carbon dioxide and water and energy, so many intermediate compounds will be formed. Whereas you cannot find any intermediate compounds in the process called combustion. In the process called combustion. And now when you take the release of energy, the energy released. So the energy will be released at several stages, not all at once. First stage, second stage, third stage, like that. When during the oxidation of glucose, there will be release of energy in several stages, in several steps. Whereas when you take combustion, energy, whatever is present in that, whatever is present in the sugar, what will happen? It will release at once. It will release at once. Okay? And finally, energy is released in the form of ATP. I already mentioned you what do you mean by ATP. Adenosine triphosphate. Energy will be stored in the form of ATP. So ATP will be formed in respiration, whereas no formation of ATP in combustion. Directly, energy will be released in the form of heat. That's all. Okay, so once again let us start out the differences now. So this is oxidation of food material. This is burning of sugar molecule. This is oxidation of sugar molecule. This is burning of sugar molecule. Here also carbon dioxide and water will be produced. Here also carbon dioxide and water will be produced. Okay, so this process is respiration. This process is combustion. Here no external heat is applied. Here external heat is applied. And here no charring occurs. Now thing will become black in color. So no charring occurs. Here first of all it will burn. First of all it will melt. Then it produces charring. That means it becomes char. Okay, it chars. And finally, it produces what? Flame. It produces flame. In several intermediates will be formed in respiration. No intermediates will be formed in combustion. No intermediates will be formed in combustion. And now, when you take this, energy is released in several stages in the process of respiration. But when you take the process of combustion, energy is released at once. Energy is released at once. Okay, and finally, energy is released in the form of what? ATP. High energy phosphate bonds will be formed in the process of respiration, whereas no formation of ATP, energy is released in the form of heat. Here, energy is released in the form of heat and also in the form of ATP. So these are the differences between respiration and combustion. Respiration and combustion. Now to prove combustion, what is happening? I told sugar will charge, I told sugar will melt, I told sugar will give energy. So you have to prove all this. This is called combustion of sugar activity. What is this activity called? Combustion of sugar activity. In the previous video, in the previous class, we have seen anaerobic respiration in the school laboratory. There we have used the experimental material called yeast. Our here experimental material is sugar. Understood, ma? So there we are going to prove anaerobic respiration. Here we are going to prove. Now we have listed so many things. We have listed so many things that this will happen, this will happen. We are going to prove all this through this experiment. This is called combustion of sugar activity. What is this called, ma? Combustion of sugar activity. So what did I say you for any experiment to write? 5 subheadings should be there. First one is aim, second one is apparatus, third one is procedure, fourth one is observation, and fifth one is inference. Okay, first one is what? Aim, apparatus, procedure, observation, inference. Okay, now let us start with the aim. So what is our aim? To prove the combustion of sugar. We have mentioned few points in it, that first of all sugar will melt, it will charge, it will produce energy all at once, and it will give energy in the form of heat. All that we have to prove through an experiment. So this is an experiment to prove combustion of sugar. So this activity is called as combustion of sugar activity. Combustion of sugar activity. So firstly, what is our aim? To observe the combustion of sugar. To observe the combustion of sugar. And next one, what are the apparatus what we are taking is. So first of all, we need what solution? Sugar solution. So we have to take glucose. We have to take what? Glucose. We have to take test tube. We have to take test tube. See, we can see this here. This is the test tube which we are going to use. Okay, test tube. And this is called delivery tube. If you clearly observe here, ma, this is called delivery tube. What is this, ma? Delivery tube. And in this test tube, you have to take, here we are going to take lime water. We are going to take what? Lime water. And here we have to arrange a cork, and all these should be set onto the stand. So this is a stand what we are going to use. Okay, so now what we are going to do is, first of all, take glucose. Glucose in a test tube, and we have to arrange the apparatus like this, and we have to burn the glucose solution. So we need what? A spirit lamp or a Bunsen burner. Okay, so this is the Bunsen burner. This is the stand where the whole apparatus is going to be set up, and these are the test tubes. One with lime water, other one with glucose solution. And to arrange the delivery tube, we have to use one molded rubber cord. One molded rubber cord. Okay, now first of all take so let us start the procedure. So these are all the apparatus what we are using. Let us start with the procedure. Let us start with what? Procedure. Now, so when you take the procedure, small amount of glucose is taken. In which test tube? In this test tube. Small amount of glucose is taken. A small amount of glucose is nothing but in a sugar solution. Or else you can take sugar directly, whatever it is. Okay. So first of all, we have to take small amount of glucose. Small amount of glucose in a test tube. Small amount of glucose in a test tube. And it is closed with what? Cork. It is closed with what? Cork. One molded cork. In that one hole, what will happen? One delivery tube will come out. We will arrange a delivery tube so that we have to collect the gas. And why did we take lime water here in this test tube? To test whether by the combustion of sugar, carbon dioxide will be released or not. To prove that, what we are using? Lime water. If the gas released is carbon dioxide, obviously the lime water will change into milky white. This is an indication that the gas released is carbon dioxide. Carbon dioxide. Okay. So we have to cover it with what? Close it with what? Cork. Okay. And the apparatus is fixed onto the stand. The whole apparatus should be fixed onto the stand and heated over the flame. So you can clearly observe here, ma, I have arranged a Bunsen burner for you here. It is burning and it is making this glucose solution to burn. Okay, so we have to arrange a flame for it. We can use Bunsen burner or else you can use for a lamp. Okay, and after certain time you can find that the sugar melts. The sugar melts. The sugar melts. And later on, if you observe, you continuously start burning it. Continuously supply heat to you. What will happen? First of all, the sugar will melt. In the point what we have mentioned also. Here, first of all, the sugar will melt. Okay. So later on, it becomes char. Nallaga, boggulaga avutunda leda. We have to check it. Okay. So it will char and produce. Finally, after it becomes charring, that means after it chars, after the charring occurs, immediately if you observe the lime water turns milky. The lime water turns what? Milky. The lime water turns milky white. So here carbon dioxide is released, water and energy. So when it melts, it releases what? Water. Okay, and the carbon dioxide is delivered through this delivery tube and changing this lime water into milky white. Lime water into milky white. So first of all, what did we observe? We observed that sugar has char. Char means what? Nallaga avada gurtupettukovali. Okay, charring. Charring is nothing but becoming black in color. Okay, and if you continuously supply heat energy, it will melt and it will produce flame. It will produce flame, and the heat is liberated at 10 times. You can feel that the heat is liberated. You can feel that the heat is liberated. So when the glucose burns, CO2 and water are produced. So this is to prove that combustion of sugar activity. So on a whole, we can say that both work on the same principle, but there are few differences between combustion and respiration. So meet you back in the next class, ma. Get ready for the next class.